Class, let's start our fourth session of trigonometry. In the previous class, I have given you the homework in which the one question was sin theta upon cot theta plus cosec theta is equals to 2 plus sin theta upon cot theta minus cosec theta. How many of you were able to solve this? Let's see. Here we have to prove sin theta upon cot theta plus cosec theta is equals to 2 plus sin theta upon cot theta minus cosec theta. Now here we can write this expression as sin theta upon cot theta plus cosec theta is minus sin theta upon cot theta minus cosec theta is equals to 2. Now we will prove that this LHS is equals to RHS, which is 2. So starting from LHS, what you will get? On taking sin theta common, we will get sin theta by 1 upon cot theta plus cosec theta minus 1 upon cot theta minus cosec theta. Now solve these two terms, what you will get? You will get LCM as cot theta plus cosec theta into cot theta minus cosec theta. Cot theta plus cosec theta into cot theta minus cosec theta. And in the numerator, you will get here cot theta minus cosec theta minus cot theta, and this plus will be changed into minus because of this minus sign. You will get minus cosec theta. This cot theta and minus cot theta will be cancelled out. Here you will get sin theta minus 2 cosec theta, and here you will get cot theta square theta minus cosec square theta because of a plus b and a minus b. Now as sin theta minus 2 cosec theta, and as we know as cosec square theta minus cot square theta is equals to 1. So here we can write minus 1 because here we have cot square theta minus cosec square theta, not cosec square theta minus cot square theta, because minus sign here is common. So you will write here minus 1. Minus minus cancel. You will get sin theta upon 2 into 1 upon sin theta, as sin theta is equals to 1 upon cosec theta. This sin theta will be cancelled. It will be equals to 2 equals to RHS. Hence proved. Now let's see another question. Here we have proved that cosec theta minus sin theta into sec theta minus cos theta is equals to 1 upon tan theta plus cot theta. Here we will solve LHS, RHS both, and we will equate both the equations. Now let's see LHS. What we have? Cosec theta minus sin theta into sec theta minus cos theta. Convert this cosec and sec in the form of sin and cos. What you will get? As cosec theta is equals to 1 upon sin theta and 1 upon sec theta is equals to cos theta. Or you can write 1 upon cos theta is equals to sec theta, same meaning. What you will get? You will get 1 upon sin theta minus sin theta 1 upon cos theta minus cos theta. On opening the brackets, here you will get 1 minus sin square theta sin theta and 1 minus cos square theta cos theta. Now as we know, sin square theta plus cos square theta is equals to 1. So 1 minus sin square theta is equals to cos square theta and 1 minus cos square theta is equals to sin square theta. You can write here cos square theta into sin square theta upon sin theta into cos theta. This sin theta cancel, this cos theta cancel, you will get sin theta cos theta. Mark this as 1. Now solve RHS. What you will get in RHS? In the RHS, you have 1 upon tan theta plus cot theta. Convert them in the form of sin and cos. You will get 1 upon sin theta upon cos theta plus cos theta upon sin theta. Again, on solving this, you will get 1 upon sin square theta plus cos square theta upon sin theta cos theta. Now as sin square theta plus cos square theta is equals to 1, so here you will get sin theta upon cos theta upon 1 sin theta cos theta. Mark this as 2. So from 1 and 2, you will get LHS equals to RHS. Now here in this question we have 3 terms. One term is prove that 1 plus tan square A upon 1 plus cot square A is equals to the second term, the middle term, 1 minus tan A upon 1 minus cot A whole square, and the third term which is equals to tan square A. Now here we will prove that both the terms, the first term and the middle term are separately equals to the third term tan square A. Now let's see the first term. Here 1 plus tan square A upon 1 plus cot square A. As we know, 1 plus tan square A is equals to sec square A and 1 plus cot square A is equals to cosec square A. So here we can write sec square A upon cosec square A. And sec square A will be equals to 1 upon cos square A and cosec square A will be equals to 1 upon sin square A, as sec and cosec are reciprocal to cos and sin respectively. Here we will get sin square A upon cos square A, which is equals to tan square A. So here we have proved that the first term is equals to the third term. Now we will prove the middle term is also equals to the third term. Middle term one minus tan A upon 1 minus cot A whole square. Now convert this tan A and cot A in the form of sin and cos. What you will get? 1 minus sin A upon cos A upon 1 minus cos A upon sin A whole square. Now open the bracket, what you will get? Cos A minus sin A upon cos A and whole upon sin A minus cos A upon sin A, which will be equals to cos A minus sin A upon cos A into, it will be sin A upon sin A minus cos A. Now if we take minus sign common here, then you will get cos A minus sin A. So therefore here we have minus sin A upon cos A, as this will give minus 1. So here we will get minus tan A whole square, which will be equals to tan square A. Suppose you have problem based on providing identities involving square root of trigonometric expression. Then use the following information whichever is required. First, if square root of 1 plus sine theta occurs in the denominator, multiply and divide by 1 minus sine theta. And if square root of 1 minus sine theta occurs in the denominator, multiply and divide by 1 plus sine theta. Here when you have 1 plus sine theta, you will multiply and divide by 1 minus sine theta. And if you have 1 minus sine theta, you will multiply and divide by 1 plus sine theta, like in the case of conjugates. And if 1 plus cos theta occurs in the denominator, multiply and divide by 1 minus cos theta, under root 1 minus cos theta. And if under root 1 minus cos theta occurs in the denominator, multiply and divide by 1 plus cos theta. Same like the case of conjugates. Let's see a question related to this. Now what we have here, prove that under root 1 plus cos A upon 1 minus cos A is equals to cos A k plus cot A. Now what is the denominator here? Under root 1 minus cos A. So as by the working rule, we will multiply and divide it by under root 1 plus cos A, not 1 minus cos A, like the case of conjugates. So LHS will be under root 1 plus cos A upon 1 minus cos A. Square root of 1 minus cos A is in the denominator, so multiply with 1 plus cos A. Square root 1 plus cos A upon 1 plus cos A. Now 1 plus cos A, 1 plus cos A. It will be 1 plus cos A whole square. And in the denominator you have A minus B, A plus B. So it will be A square minus B square. Okay. Now as 1 plus cos A whole square, as we know 1 minus cos square A will be equals to sin square A, so it will be sin square A. Now both the terms are now perfect square, the root will be enumerated, you will get 1 plus cos A upon sin A. Now break the numerator, you will get 1 upon sin A plus cos A upon sin A. Now as 1 upon sin A is cos A k, and cos A upon sin A is cot A, which is equals to RHS, hence proved. Now your homework is, first question is prove that 1 minus sin theta upon 1 plus sin theta is equals to sec theta minus tan theta whole square. Second question is prove that tan A upon 1 minus cot A plus cot A upon 1 minus tan A is equals to 1 plus sec A into cosec A. And third question is prove that square root of sec theta minus 1 upon sec theta plus 1 plus square root of sec theta plus 1 upon sec theta minus 1 is equals to 2 cosec theta. Thank you.